Okay, today we're going to look at section 6.1, which is the area between two curves. So to kind of start out with our initial idea is suppose we had a function here that we'll call f of x, and we had a second curve kind of down here that we'll call g of x. And let's say here's the y-axis and here's the x-axis. And let's say at a particular point, so let's say we'll call this point here, we'll call that A. So at point A, I want to know what's the distance between g of x and f of x. So I want to know what's this little vertical distance here. So what I can do is I can figure out the full distance from here all the way up to f of x's value there. I can figure out the distance from here up to where g of x is. And then if I subtract these two amounts, so I subtract the g of x from the f of x, that'll cancel all the in-betweens, or all the stuff where they overlap, and the leftover bit will be the same height as you have there. So basically, kind of what we're saying here is, if I wanted at A, if I wanted to figure out what's the distance right here, the vertical height of that bar, that would be f of A. So the function, f function, the top function at A minus the bottom function evaluated at A. So we get that. This idea kind of can be extended where if we have two graphs, or again, let's say we have two curves again. So here's y, here's x. Here's f of x up here. And here's g of x down here. And we wanted to find the area between these two curves, say from A up to B. So we wanted to find what is all of the area in between these two. Well, we're going to kind of use similar reasoning and say, well, that would be the integral from A up to B of f of x dx, which is all the area under f, and we would subtract from it all the area under the curve of g of x. And this subtraction here would represent the area in between those two curves. We could note that you can combine these up into a single integral of the f of x minus the g of x function. Linearity lets us combine it up that way. So these kind of initial ideas here, hopefully we kind of say, okay, that kind of makes sense that the distance between them would be that. And then you can kind of extend that idea over here to come up with the area. This argument for the area kind of makes sense. So our book gives us the first equation that's going to say area between two curves, or between two graphs, I guess we could say. Our book uses the notation, so it's integral from A up to B. It's going to be y top, so the top function, minus they use y BOT for the bottom function, dx, which in the little drawings we were drawing up there, that was A up to B. And since in our little drawings f of x was the top function and g of x was the bottom function, that would turn into the integral of f of x minus g of x dx. So this right here kind of tells us a method of finding the area between two curves. You figure out who's the top function, you figure out who's the bottom function, and you integrate the top function value, or the top function's equation minus the bottom function. So we're going to do a couple examples with this. So first example, they give us a function f of x equals x squared minus 4x plus 10. And they give us the function g of x equals 4x minus x squared. And they want us to find the area between the graphs. Over 1 is less than or equal to x is less than or equal to 3. So what we're going to have to do with this, we need to sketch these two graphs and figure out who's the top function and who's the bottom function. So what I'm going to do is I'm going to use the vertex equation. This is back from, I'll do my scratch work in a different color. This is kind of back from Algebra 2, is if you have a function that's ax squared plus bx plus c, negative b over 2a will tell you the x value of the vertex, and f of negative b over 2a will tell you the y value of the vertex. So let's start graphing the f function. We know we're going from 1 up to 3. So here's 1, here's, whoops, I've really spaced these badly. Let's try that again. So here's 1, here's 3. I'm going to figure out what is f of 1. F of 1 is 1 squared minus 4 plus 10. So 1 take away 4 is negative 3. Negative 3 plus 10 is 7. So f of 1, 2, 3, 4, 5, 6, 7. It's way up here at 7. F of 3, since I'm only looking at the region 1 up to 3, I'm trying to figure out where does, I know this is a parabola opening upwards, so I'm figuring out where does the parabola start. It's going to make a parabola shape, I guess. I need to figure out where it stops, and I need to figure out the vertex of the parabola, and then I'll do the same thing with this g of x. So when I put 3 in here, 3 squared is 9, minus 4 times 3 is 12, plus 10. So negative 12 plus 10 is negative 2. If you have 9 and you take 2 away, that is also 7 in this situation. So our starting and our stopping point of the f of x function are at the same place. I'm going to do negative b over 2a to figure out the x value of the vertex, and then I'll plug that in to figure out the y value. So I get negative 4 over 2 times a, the number here in front of x squared is 1. This is going to be 2. So I know the x value of the vertex is at 2. Then to get the y value, I figure out what's f of 2. 2 squared is 4. Negative 4 times 2 is negative 8, plus 10. So let's see here. Negative 8 plus 10 is negative 2. No, it's positive 2. 2 plus 4 is 6. So this one here is at 6. So we just kind of have a very shallow, the kind of shallow part here of our f of x graph. So we're going to repeat this stuff to figure out the g of x's graph, and then we'll generate the equations to solve these. So for g of x, I know g of 1, that would be 4 times 1 is 4, minus 1 squared is 1. So 4 minus 1 is 3. So g of 1, we start up here at 3. Our stopping value is going to be g of 3. 4 times 3 is 12. Take away 3 squared is 9. 12 take away 9 is 3. So our stopping value is also 3. And if I do negative b over 2a, b in this case is x's number, so that's negative 4 over 2 times a is the number in front of x squared, which is negative 1. So that's negative 4 over negative 2 is positive 2. So its vertex also happens to fall at 2. And g of 2 is 4 times 2 is 8, minus 2 squared is 4 is 4. So 3, 4, here's the g of x function. So we can see for this expression here, the area we're trying to calculate is from 1 up to 3. We want the area in between these two graphs here. So So we're going to do integrate the top function minus the bottom function over the interval. So we're going to say, all right, the top function is f of x the whole time. So we'll have the integral of 1 up to 3 of f of x, which is x squared minus 4x plus 10. And then we subtract from it the g of x function. We need to make sure that all of the g of x function sees the negative sign, because the g of x function, this is the bottom function, so we're going to subtract the bottom function. So 4x minus x squared, 4x minus x squared goes down there. And then we'll distribute our negative sign, and we'll solve the thing out. And that'll tell us the area. So we got x squared minus 4x plus 10 minus 4x plus x squared dx, like that. We're going to combine like terms, so we get x squared plus x squared is 2x squared. Negative 4x minus another 4x is negative 8x. 10 plus nothing is 10. And then we're going to calculate the antiderivative here. So x squared, when I go to integrate it, goes to 1/3 x cubed. So I have 1/3 x cubed times a 2 is a 2/3 x cubed. X by itself goes, when I integrate it, goes to 1/2 x squared. So I have negative 8 times a half, which is negative 4, times x squared. And 10, when we integrate it, we just put an x after it. And we evaluate these from 1 up to 3. So we're going to use fundamental theorem of calculus part 1 and say we get these evaluated at 3. 3 cubed is 27. Let's see here. 3 squared is 9. And then 3 times 10 is 30. We subtract it. This all evaluated at 1. So that would be 2/3 times 1 minus 4 times 1 plus 10 times 1. So let's see what we end up with. 3 cancels into 27, leaves a 9. 2 times 9 is 18. This is minus 36 plus 30. So negative 36 plus 30 is negative 6. 18 take away 6 is 12. So we end up with 12 there. Over on this side, let's see, what do we have? Minus, we got a 2/3. Negative 4 times 1 is negative 4. Negative 4 plus 10 is plus 6. I need to get 6 in terms of thirds, so I multiply it by 3 over 3. That's 18 thirds. 18 thirds plus 2/3 is 20 thirds. So I need to get the 12 in terms of thirds, so we can subtract these together. This is going to be 36 thirds minus 20 thirds. 36 take away 20 is 16 thirds. And this will be the area between those two functions. So basically, when we set it up, we had to do the top figure out, first of all, graph it and figure out who's the top and who's the bottom. Then it's top function minus the bottom function. I put the bottom function in there in parentheses to make sure the negative hits all the terms. We get our expression like that. We combine like terms, integrate it, and evaluate it, and then it tells us the area between the curves. So moving on to the next one. It's going to just get us a little bit more practice with finding the area between curves. So on this one, we want to find the area between curves of, they give us f of x equals x squared minus 5x minus 7, and they give us g of x equals the line x minus 12, and they tell us we're doing this over the interval -2 up to 5. Oops. Okay, so first of all, we're going to have to graph all these to get an idea of what the graphs look like. So let's start graphing the parabola first. We'll use the f of -2. We'll figure out what's the y value at -2. -2 squared is 4. -2 times -5 is positive 10. Then we get minus 7. So this is 14 minus 7 is 7. So our first function that we're dealing with here, the f function, at negative 2, we're up at 7. Okay. Then we're going to say, all right, where does this thing stop? It stops at f of 5. F of 5 would be 5 squared is 25, minus 5 times 5 is 25, minus, what is that, minus 7? Is that right? 5 squared is 25, minus 25 minus 7. So f of 5 I'm getting is negative 7, and that seems not like what I'm expecting. I was expecting positive 7. So let's see what we're looking at f of 5. 5 squared is 25, minus 5 times 5 is 25, minus 7, so we get negative 7, I guess. Hang on. That's not... I'm missing something up here pretty badly. Like this one was there. This one's 25. Take away 25. Take away 7. So it says out here at 5. 3, 4, 5. We're supposed to be, or I guess we're down here at negative 7, but the book has it back up here at positive 7. So obviously I feel like I've messed something up, but I guess we just got to go with it. That's this, as far as I can tell. I feel like I'm maybe making a sign error here, but we're just gonna let stuff go. So 5 squared, that's definitely 25. 5 times 5 is definitely negative 25. That's negative 7, so it's negative 7. So out here we are 2, 3, 4, 5, 6, 7. We're kind of down here at negative 7. I guess when we find the vertex, maybe that'll tell us what's going on. To find the vertex here, we're going to do we're going to do negative b over 2a. So negative b is negative 5 over 2 times a is 1. So this is 5 halves, which is 3.5. And then we want to find f of 3.5. So I'm going to do that in the calculator real quick just to speed stuff along here. So we get 3.5 squared minus 5 times 3.5 minus 7 is, let's see, what is that? Negative 12.25. Okay, so I guess this is okay. So that's negative 7, 10, 11, 12. So it's negative 12 and a little bit at, whoops. Oh, I made a mistake. 5 halves is 2.5. So when I go to plug this into the calculator, it's going to be 2.5 squared. F of 2.5 is negative 13.25. So we're way down here. Negative 13 and a little bit, and that would be about there. Our parabola has a y-intercept of negative 7. 4, 5, 6, 7. So we're going to try to draw our parabola. It's going to look kind of something. I'm doing a bad job here, but it's going to look something like that. So we have this curve. We have this curve of the parabola there. Next, we need to sketch the line x minus 12. So the line of x minus 12, that has a y-intercept of negative 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has a slope of up 1, right 1. So it's up 1, right 1. And let me see what the stopping point, because we know that this part here is just going to kind of trail off as a straight line that way. But let me see, where do we stop at f of 5, or sorry, g of 5. So g of 5 would be 5 minus 12, which is negative 7. So g of 5 is negative 7, which happens to be right here. So our expression, our line g of x looks like this. our function f of x looks like that. And the area that we're trying to keep between these, this is going to be -2 up to +5. So the area we're trying to find here, it's kind of two sections. We have from -2 all the way down here to this. We have this whole kind of triangle shape. But since the functions switch who is the top function and who is the bottom function, the second part that we're kind of trying to find the area between out here, we're going to have to split this integral up into two different places. So we need to figure out what's the x value. We need to figure out what's the x value of the intersection. And the reason I have to do that, I need to split my integral there. Because the top function and bottom function switch places. So basically, we're up until we get to whatever this x value is that we're going to calculate in a second, f of x is the top function, g of x is the bottom function. Then they flip over at whatever this point is, and then g of x is the top function, and f of x is the bottom function. So to figure out how do we calculate where the x value of the intercept is there, we're going to just set these two expressions equal to each other. So x squared minus 5x minus 7. I want to know where x squared minus 5x minus 7 is equal to x minus 12. So we'll subtract the x across. So say x squared minus 6x. We'll add the 12 on over. So, -7 plus 12 is plus 5 equals 0. So there's going to be, let's see, this factors as x minus 2. No, does this factor at all? Oh, it's going to be 5 and 1. No, it's not going to factor. Well, no, it does factor. Let's see, so this will be x minus 5 times x minus 1 equals 0, which says either x is 5 or x is 1. These are the intersection points. We already found x equals 5 over here. That one we found as the stopping end of our interval. They crossed each other again. This one right here, the x value of that intersection is x equals 1. So what we're going to do to set up our actual integrals, we're going to say, all right, we have the integral from -2 up to 1. We're going to do kind of this triangle region first. F of x is the top function, g of x is the bottom function. So this will be the integral from -2 up to 1 of the top function minus the bottom function. And then we're going to add to it the integral from 1 up to 5. So that's this part here, starting at 1, stopping at 5. This time g of x is the top function, f of x is the bottom function. So this will be g of x minus f of x dx. So now we're going to plug in what's what here and evaluate these integrals. So we have -2 up to 1. F of x is x squared minus 5x minus 7. And we're going to subtract from it g of x, which is x minus 12 dx. We'll make sure the negative distributes on that. Then we're going to add to it the integral from 1 up to 5 of g of x is x minus 12, and we'll get minus, this will be x squared minus 5x minus 7 dx. So we'll check that the negative distributes to everybody there. So we get the integral from -2 up to 1 of x squared minus 5x minus 7 minus x plus 12 dx plus the integral from 1 up to 5 of x minus 12 minus x squared plus 5x plus 7 dx. So I'm going to go through and combine like terms on both of these, then we'll take their antiderivatives and evaluate them. So we have x squared here Minus 5x minus another x is minus 6x. Negative 7 plus 12 is plus 5 dx plus the integral from 1 up to 5 of, this will be negative x squared. X plus 5x is plus 6x. Negative 12 plus 7 is minus 5 dx. So to integrate x squared is going to go to 1/3 x cubed. The x by itself will go to 1/2 x squared. Negative 6 times a half is negative 3x squared. And then we get plus 5 times x. We're going to evaluate that from negative 2 up to 1. And then we get plus, on this one we get negative 1/3 x cubed. This one here goes to 1/2 x squared. Half of 6 is 3. So that's plus 3x squared minus 5x. We evaluate that from 1 up to 5. So basically what we're going to get is, and I'm going to use some of the previous work here to kind of try to speed this up a little bit when we calculate these integrals. We get basically 1/3 evaluated at 1 cubed minus 3 times 1 squared plus 5 times 1. So we'll get that whole bit. It's just this whole expression with 1 plugged in. We subtract from it that whole expression, should be 1/3, with negative 2 plugged in. We add to it this whole expression with 5 plugged in. And we subtract from it this whole expression with 1 plugged in. This would be minus 5 times 1. And if we total this all up, either type in a calculator or take a while and do it by hand, we end up getting that this will be 113 over 3. You just need to evaluate all these out, which in interest of time we'll just assume we can either put it in a calculator or just do it by hand. It'll just take a little bit. So moving on to example 3 here. They want us to find the area of the region. So they want us to find area of the region bounded by the following expressions. Y equals 8 over x squared. Y equals 8 over or 8x, and y equals x itself. So 8 over x squared, this is a reciprocal, or not reciprocal, but this base graph 1 over x squared looks like this. And this has been vertically stretched by 8. So our graph's going to kind of look something like that. So this is our 8 over x squared graph. The line 8x, that's a line here, crosses through the origin with slope 8, so it would be going upwards very rapidly with a steep slope of 8. In our line y equals x, that would just be a line here like that. So the region they're wanting us to find the area of is this kind of triangle shape. That sort of has the 8x line at the top initially, and then it switches to the 8 over x squared line being on top for the second part. So there's going to be kind of a couple pieces of information we need in order to solve this. I need to know, where is this intersection? What is the x coordinate of that intersection? I need to know what's the x coordinate of this intersection. And since who the top function is changes from 8x to 8 over x squared right here, We're going to have to split the area of this expression. Use two different colors here. We're going to have to kind of split our integral right through the middle. And the first part of the integral will be based off of this side over here, where the green function's the top and the blue function's the bottom. And then the rest of the integral will be based off of this side over here, where our orange function, the 8 over x squared, is the top, and the blue function, x itself, is the bottom. So we have to split the integral up because the top function changes at some point through there. So let's calculate the x value here where this occurs. So we're going to figure out this x value here first. In order to do that, I'm going to take my 8 over x squared graph, and I want to know where is 8 over x squared equal to the 8x graph. So I can multiply x squared across, divide both sides by 8, take the cube root, and we get 1 equals x. So this occurs at x equals 1. That's the x value where this one flips over. And then we need to see what's the x value out here. So to get that, I'll take my 8 over x squared. I'll set it equal to the other line here, x. This says 8 is x cubed because the x squared will multiply across. We'll take cube root of 8 is 2. So we get 2 is x. And so our integral is going to go from 0 up to 2. We're going to have to split it up here in the middle at 1. So to calculate the integral, we basically have the integral from 0 up to 1 of the top function here is 8x minus the bottom function is just x itself. So that's for the first region. Plus we integrate from 1 up to 2. This time the 8 over x squared, which we should note 8 over x squared is the same as 8 times x to the negative 2. And we're gonna, that's the top function, and the bottom function is the blue function, so we subtract x from it. And this is our integral that we want to basically calculate. So if I look at this, 8x minus an x is 7x. Here there's nothing really nice we can algebraically mix together, so I'm just going to try to, I guess let's start to actually integrate this one. So if we have x itself, we're going to need to add 1 to the power, so that'll be x to the negative 1. And we don't want an extra negative created when the negative 1 drops down, so we're going to put a negative there. So when I integrate x to the negative 2, that part's going to go negative x to the negative 1, and there's an 8, so we get minus 8x to the negative 1. And x itself is going to go to minus 1/2 x squared. That's going to be evaluated from 1 up to 2. So now over here, x itself, when I integrate it, goes to 1/2 x squared. So I have 7/2 x squared from 0 to 1 plus negative 8x to the negative 1 minus 1/2 x squared from 1 up to 2. So let's plug numbers in and kind of evaluate stuff. If I put a 1 here, 1 squared is a 1, so I just get 7/2. Minus, when I put 0 in, 7/2, 0 squared is 0 times 7/2 is 0. Plus, when I put 2 in, let's see here, 2 to the negative 1 power, this would become a negative 8 over 2, which would be a negative 4. And then if I put 2 in here, 2 squared is 4, cut it in half. 4 cut in half is 2, so that would be negative 4 minus 2. And then, let's see, what else do we get? We have to subtract from it when I put 1 in, so this is just going to be negative 8, and this will be minus 1/2. Something like that. So let's see here. 7/2 is 3.5. Got 3.5 plus negative 6. And then this would be 8.5 is minus negative 8.5 is plus 8.5. So 3.5 plus 8.5. 3 plus 8 is 11 plus 0.5, that's 12. So it's going to be 12 minus 6, which equals 6. So that's the area between the two curves. Again, we had to split it up kind of at this point here because who the top function and who the bottom function were top function changed at that point. The bottom function stayed the same the whole time. So you had to kind of flip who was on the top, swap them out at the point x equals 1 in that situation. The last thing that's in this section is if we look at doing stuff along the y-axis. So if we integrate along the y-axis, then so basically if you have equations where you want to do, let's say we wanted to look at the integral from -6 up to 6 of y squared minus 9 dy. If we graphed that, if it was x squared minus 9, this would be the regular parabola, and it would shift down 9. When it's y squared's base parabola. So just the graph of y squared, the base parabola for that is, it's kind of like a parabola on its side. And subtracting 9 would move it, 5, 6, 7, 8, 9, would move our function down kind of like this. So if we wanted to do -6 up to 6 on a graph like that, what we would be finding is the signed area here would be positive, the signed area in here would be negative, and the signed area out there would be positive again. So we would be totaling up the signed area over that expression. So this kind of tying this together with what we've been looking at, if you want to do the area between the graphs, in this situation, we would have the integral from c up to d, and it's going to be x of the right minus x of the left. So instead of top and bottom, we deal with left and right. Top is like being the right, and bottom is like being the left. And we use this equation to kind of help us out with our stuff here. So our final example, they're going to give us a graph, and they're going to tell us what the equations are, and they want us to calculate the area between them. So for this one, they tell us that h of y is y squared minus 1, and they tell us g of y is y squared minus 1/8 y to the 4th plus 1. They want us to find the area between the graphs. And they give us the graph of this thing. They don't tell us which function's which, but they show us a graph. So here's -1, and we have, here is 2. Here's -2. And we have kind of a function that comes in, turns around at 2. Oops. Comes in, turns around at 2, comes down to 1, goes back out at -2, and goes like that. And the other function starts here at -1 and heads up and intersects at the point. We don't know the x value, but we know the y value is 2. We know the y value down here is -2. So the region we're trying to find, we're trying to find the area in between these two curves. So I need to identify who's the left function, who's the right function. And our integral is going to start down here at -2, and we're going to integrate all the way up till we get to +2. So we're going to have the integral from -2 up to 2 of, it'll be the right-hand function minus the left-hand function dy. And based on these, x squared minus 1 is a parabola, so we know that this one right here is going to be our h of y function, because the line here is just a parabola. This one here with the 4th power can make kind of this weird wiggle, so that one will be our g of y function. So the region we're looking at is bounded from, starts at -2, stops at +2. So we're going to be looking for our integral of, we have -2 to 2. The right function is going to be g of y, because that's on the right-hand side from negative 2 to 2. So we have g of y minus the left-hand function, which will be our parabola, because over the region between 2 and negative 2, the parabola is to the left the whole time, so that'll be our h of y function. So we'll get that. So we'll say, all right, this is going to be integral from negative 2 up to 2. G of y will be y squared minus 1/8 y to the 4th plus 1. So y squared minus 1/8 y to the 4th plus 1. And the h of y function is y squared minus 1. So we get negative 2 up to 2. Who the function was on the right and who the function was on the left for this particular region don't change. If we were told, instead of just the area between them, if we were told to integrate from like negative 3 up to positive 3, then who's the left-hand function and who's the right-hand function switch places. So we'd have to split the integral up the same way that we did when the top and the bottom functions swapped places. So we get y squared minus 1/8 y to the 4th plus 1. Oops. We're going to distribute the negative here, so we get minus y squared plus 1 dy. Okay, so we get integral from negative 2 up to 2. We have a negative 1/8 y to the 4th. Y squared and negative y squared cancel. We get a plus 2 dy. So we get this is going to equal, we'll take the derivatives here. This will be 1/5 y to the 5th. That's what the antiderivative of y to the 4th goes to. So the 1/5 will multiply to the negative 1/8, and we'll get negative 1 over 40 y to the 5th plus 2y evaluated from negative 2 up to positive 2. And so basically what we'll get is negative 1/40 times 2 to the 5th plus 2 times 2 minus negative 1/40 negative 2 to the 5th plus 2 times negative 2. And if we total that all up, we will end up with eventually getting 32/5 out of it. So if we just work this through, it turns into that. So we're going to stop there, and that's basically it for 6.1.